Good morning, viewer. Welcome to our Fossil TV USA. Here is the breaking news from Europe. Yes, European scientists say they have made a major breakthrough in their quest to develop practical nuclear fusion, the energy process that powers the stars. The UK-based Jet Laboratory has smashed its own world record for the amount of energy it can extract by squeezing together two forms of hydrogen. If nuclear fusion can be successfully recreated on Earth, it holds out the potential of virtually unlimited supplies of low carbon, low radiation energy. The experiments produced 59 megajoules of energy over 5 seconds, that is called 11 megawatts of power. This is more than double what was achieved in similar test back in 1997. It is not a massive energy output, only enough to boil about 60 kettles worth of water, but the significance is that it validates design choices that have been made for an even bigger fusion reactor now being constructed in France. The jet experiments put us a step closer to fusion power, said Dr. Joe Mellons, the head of operations at the reactor lab. We have demonstrated that we can create a mini star inside of our machine and hold it there for 5 seconds and get high performance, which really takes us into a new realm. The ITER facility in southern France is supported by a consortium of world governments, including from EU, that is mean European Union member states, the US, China, and Russia. It is expected to be the last step in proving nuclear fusion can become a reliable energy provider in the second half of this century. Operating the power plants of the future based on fusion would produce no greenhouse gases and only very small amounts of short-lived radioactive waste. These experiments we have just completed had to work, said JET CEO Professor Ian Chapman. If they had not, then we had to have a real concern about whether ITER could meet its goal. This was high stakes, and the fact that we achieved what we did was down to the brilliance of people and the trust in the scientific endeavor, he told to the reporter. Fusion works on the principle that energy can be released by forcing together atomic nuclei rather than by splitting them, as in the case of the fission reaction that drive existing nuclear power stations. In the core of the sun, huge gravitational pressures allow this to happen at temperatures of around 10 million Celsius. At the much lower pressures that are possible on Earth, temperature to produce fusion need to be much higher, above 100 million Celsius. No materials exist that can withstand direct contact with such heat. So, to achieve fusion in a lab, scientists have devised a solution in which a superheated gas or plasma is held inside a donut-shaped magnetic field. The joint European torus, seated at Culham in Oxfordshire, has been pioneering this fusion approach for nearly 40 years. And for the past 10 years, it has been configured to replicate the anticipated ITER setup. The fusion announcement is great news, but sadly, it won't help in our battle to lessen the effects to climate change. There is huge uncertainty about when fusion power will be ready for commercialization. One estimate suggests maybe 20 years, then fusion would need to scale up, which would mean a delay of perhaps another few decades. And here's the problem. The need for carbon-free energy is urgent, and the government has placed that all electricity in the UK must be zero emission by 2035. That means nuclear, renewables, and energy storage. In the words of colleagues of John Amos, fusion is not a solution to get us to 2050 net zero. This is a solution to power society in the second half this second half of this century. The French labs prepared fuel to make the plasma will be a mix of two forms or isotopes of hydrogen called deuterium and tritium. Jet was asked to demonstrate a leaning for the 8 cubic meter toroidal vessel enclosing the magnetic field that would work efficiently with these isotopes. For its second breaking experiments in 1997, Jet had used carbon, but carbon absorbs tritium, which is radioactive. So, for the latest test, new walls for the vessel were constructed out of the metals beryllium and tungsten. These are 10 times less absorbent. The Jet Science team then had to tune their plasma to work effectively in this new environment. This is a stunning result because they managed to demonstrate the greatest amount of energy output from the fusion reactions of any device in history. Commented Dr. Arthur Turrell, the author of the Star Builders, Nuclear Fusion and the Race to Power the Planet. It is a landmark because they demonstrated stability of the plasma over the second. That is called over the 5 seconds. That does not sound very long, but on a nuclear time scale, it is a very, very long time indeed. And it is very easy then to go from 5 seconds to 5 minutes or 5 hours or even longer. Jet cannot actually run any longer because its copper electromagnets get too hot. For ITER, internally cooled superconducting magnets will be used. Fusion reaction in the lab famously consume more energy to initiate than they can output. At Jet, two 500 megawatt flywheels are used to run the experiment, but there is solid evidence that this deficit can be overcome in the future as the plasmas are scaled up. ITER's toroidal vessel volume will be 10 times than of Jet. It is hoped the French lab will get to break even. The commercial power plants that come after should then show a net gain that could be fed into electricity grids. This is a long game, and it is significant that of the 300 or so scientists working as Jet, a quarter are in the early part of their careers. They will have to carry the burden of research forward. Fusion takes a long time, it is complex, it is difficult, said Dr. Athena Kapatu, who is in her 30s. This is why we have to ensure that from one generation to the next, there are the scientists, there are the engineers and the technical staff who can take things forward. Many technical challenges remain, however. In Europe, these challenges are being worked on by the Eurofusion Consortium, which comprises some 5,000 science and engineering experts from across the EU, Switzerland and Ukraine. The UK is a participant too. Its full involvement in ITER, however, will require first for Britain to associate to certain European Union science program, something that is so far has been held up by disagreement over post-Brexit trading arrangement, particularly in relation to Northern Ireland. Jet is likely to be decommissioned after 2023, with ITER beginning plasma experiments in 2025 or soon later or soon after. BN Das report for Shakti USA.